Hello, I made a video about a year ago explaining how you could set up one of these Microblox GPS modules to output the UBX binary protocol and bring that information into your Arduino program. And the focus of that was to keep the data size down and the memory usage very small. So this is the video here, I'm just replaying it so we can have a look at it. But to look at that program, this is a program here, so I managed to get it down to about 66 lines of code or something like that. But it depended on quite a few preliminary setup requirements. So one of the requirements is that you had to use the uCenter app and connect up your GPS module to the uCenter app, that's this one here. And you had to set up your module so that it would only output a certain specific message. And that was going to be the only message you would ever see coming out of the GPS. And after I put that video up, I got quite a number of requests or comments or inquiries about how we could use a different message and how we could use multiple messages, because the reason that I chose this particular message, the POS LLH message, is that it was the smallest one that I could find that had the lat long information in it. So that's those two variables there. But people wanted to be a little bit more cautious, and they wanted to also have the ability to know whether they had a valid GPS fix or not, which the information is not in the POS LLH structure, packet, message, whatever you want to call this. So they wanted to use a different message, and most people seem to want to use the nav PVT message, and that's one that's been recommended by the Microblox documentation to use over this one, which is a little bit sort of outdated, I think. So in this video I'm going to look at how you can change. If you still want to just use the one single message, that's pretty easy, but instead of using POS LLH, we'll look at how you can use the nav PVT message, which does have the GPS fix information in it. And other people were asking about how you can use multiple message types. So for example, you might be okay with using POS LLH, but you just want to use one other message type that has the GPS fix in it. So you wanted to use multiple, you want to have multiple of these messages coming in from the GPS and detect which was which as they came in and process them all correctly. So that was the other thing that people wanted to know. So that's the two things that I was asked about. And I'll also look at one other thing in this video which I wasn't asked about, but I've found very, very handy recently. And that is how you can make excuse me, all these settings that we're doing with the uCenter app here without using the uCenter app. So you can set up your Arduino to send these instructions to the GPS module itself, which is very, very handy. So we'll have a look at that afterwards as well. Alright, so this is the software almost, I think this is exactly as I uploaded it last year. And well, let's just look at the differences that we need to, if we want to first look at changing from using the POS LLH message to using the nav PVT message. So this is it over here. And I think I mentioned at the end of my other video that all you need to do to change, if you just want to use one message type only, all you need to do is change the contents of this structure to be the contents of the message that you want to change it to. So in this case, you can see over here we have the nav PVT structure includes a lot more member variables. Whoops. So this payload is about 84 bytes long, I think, in total, so it's a lot larger. But you can see in here that there's the fixed type, which is the one that people were mainly interested in. So that's included along with the lat long information as well. So it all comes in one packet, which is quite nice if you just want to deal with the one message type and keep the relatively compact source code that we had earlier. So even though that's all you had to do, it seems like people sort of still kind of stumbled over getting the exact data types that you need in the structure. And if we just have a look at that, where is it? This is the documentation for this nav PVT message. So everything's listed up here showing you the number format that you need to use, but I guess you just have to be very, very careful, and maybe they weren't careful enough and they got it a bit wrong or something. But To help people out who might be doing that in the future for other different message types, I've made a list here, or a table, and this is just using the table that you can find in the documentation if you search for number formats. So there's a table here explaining what is a U1, what is an I1, and all that stuff. So I've just taken this table and I've put it over here, showing you which type you should be using for an Arduino program for each one of those variable types. So that should help people in future if you want to look at one of these other message types and you see that the number format is this thing, then you'll know which one to use. So that's about all there was for using the nav PVT message. All we do is change the contents of the structure like that, and that's all you needed to do, but I've just for convenience or aesthetics sake, I've renamed everything to be PVT instead of POS LLH. So if we look down here, we'll see that the structure instance is called PVT, and then we're using PVT here as well. That's not really necessary, but I just thought it would be nice to do that. So that's all you need to do if you want to use another single message type. What about the case where we want to set up the GPS module to output two different messages, or two or more different messages, and we want to read them all in and process them correctly? So that's the second case, and I have another sketch here which is called UBX GPS multiple messages. So the prerequisite for using this one is you need to set up your GPS module to output the POS LLH and the status messages. And so we have the two headers there, and this time we need to look at these headers, so we have to define what they are to compare something with them later on. And then I just have an enumeration to call these message types by name. And then we have our structure that we had before. This is exactly the same, unchanged. But below that we have a second one, because now we need to look at the structure of the nav status message as well. And below that, instead of having an instance of each one of these structures, I've put them into a union so that they're going to be sharing the memory. For those that are unfamiliar with this union concept in C, it just means that whatever's listed inside this curly braces area here are all going to be placed at the exact same memory location. So we have nav POS LLH has, let's see, well, the first four members of them are all the same, aren't they? So we've got class, ID, length, and then time of week, and then down here we have class, ID, time of length, and time of week. So well, anyway, just looking at the first variable, the location of this variable in memory is going to be exactly the same as the location of that variable in memory as well. So if you change one of them, you're going to be changing the other. Just to like reinforce that, so we have an instance of this union there. So that's one of this generalized UBX message unions. And if we were to do UBX message and then this one, and then the class equals 5 or whatever, that would be exactly the same as doing this. So regardless of which one of those, the POS LLH or the status that I'm changing, these two lines here are going to take exactly the same action because these two structures are overlapping the same area of memory. So that means that the size of this union is going to be the size of whichever one of these things it contains is the largest. In this case, I think the POS LLH is a little bit larger. So size, if you did size of UBX message, you'd get the same thing as size of nav POS LLH. Anyway, that's how we store those in memory, and that means that we can have quite a lot of these different structure types in use without wasting so much memory. If you were to have a structure, an instance like this for each one, oh god, why does it do that? It's so annoying. If you were to have a structure for each one of these, you'd be adding up. This is like 32 bytes or something, and the other one's 22. But if you had sort of 6, 7, 8 types of messages, that's starting to waste a bit of memory. Anyway, so that's what a union does. And in this program, I've also added in quite a few comments to hopefully help explain things a bit better. But basically the only thing, there's a couple of things that are different. One thing is that when we get to the 4th byte of the packet or the message, now the 4th byte of the packet means that we've just read in the message header 2 bytes. So now we need to figure out which type of message we're dealing with. So I have a helper function to compare that to whichever type of message we're looking for, so in this case LLH. And if it's the POS LLH, then we set this variable to remind us which message type we're dealing with, and then we set the payload size to the expected payload size for that type of message. And then down here we just have status and status ones as well. So you'll need an if-else case for each one of the message types that you're dealing with there. And I think the only other thing that I changed was that this function originally was returning a Boolean value, and the Boolean would simply say whether we just successfully received a message from the GPS or not. Now, in addition to saying that we received a message successfully or not, we also need to know which type of message it was, so that we can copy the member values out of it later on. So I've made this return an integer, and if we look down at the part of the function where it returns this, we'll see that it's returning the current message type. So where this is used in the loop function, we can do something like this: int message type equals, and then process GPS. So if this returns, here we go. If it returns this value, POS LLH, we'll know that we just read in a POS LLH message, and we can do something using the values that are in ubxmessage.navPOS LLH. So we're just printing some things out there. Otherwise, if the message type was the status, then we'll know that we have a valid ubxmessage.navStatus. Everything in that structure will be valid. But keep in mind that that's only for one loop that it's going to be valid, because as soon as we go through this loop again, we're going to call process GPS, and this may read in some more bytes from the GPS, and then it will overwrite the contents of those structures. So if you want to keep some values around, you should keep them separately. So you would have something like long lat, long. So if you wanted to keep your lat long between loops, you'd have to have some global variables like that, and inside this if statement you'd need to copy them in so that they wouldn't be overwritten immediately in the next loop. So you'd have lat equals, where is it, lat, this one. So you need to copy out everything that you want before it gets overwritten. I'm not doing that here because I'm simply printing everything out to the serial monitor so we can see that it works. But just keep in mind that in the next iteration of this loop, your values are all going to be overwritten because they're all stored in the same union and they're all sharing the same memory. So that's just something to keep in mind. But that is how you can use multiple different message types. Bearing in mind, of course, that you've set up your GPS module to produce only these 2 UBX messages. So that brings me to the last part of this video, where I want to look at how you can set up the GPS module using the Arduino. So I'll just jump straight into a sketch that I have made that does that, and it will look a bit scary at first, but it's not too bad once we figure out where these numbers came from. So in this sketch here, which I've called set message outputs, we have a huge big array of bytes basically. So this is just a huge long string of bytes, one after the other, and I've separated them into lines so that we can see a little bit clearly what they actually mean. And don't worry about where they came from just yet, but in the setup function we begin a software serial connection. So this is just using the same software serial connection that we've had for all of the other ones. And then all we do is loop over that array of bytes, the size of that array, and write each one of those bytes to the GPS module. And there's a little bit of a delay here. I actually got this from the MultiWii source code, so it's not nothing new, but I haven't been using it until now, and it's really, really handy. So I thought I would mention it in a video as well. And that's all it does. So in the loop function, I don't have anything. So all this is going to do is set up the configuration of the GPS module. So where did these bytes come from? Well, if we jump over to the uCenter configuration program, and I'll just start from the beginning again. So in the view menu, you open up the messages view, and then under here you'll look under UBX config and then messages. So I'll just make this a little bit bigger for us. Doesn't make much difference, does it? Anyway, so when you select this messages thing here, now notice I have not connected this to the GPS module. You don't need to. That's the really neat thing about what we're doing with the Arduino, setting the parameters. So anyway, when you select messages, you'll see over here there's a pull down list with a bunch of messages, and somewhere near the top we'll see some that we are familiar with, we should be familiar with by now. There's POS-LLH, nav POS-LLH, nav status, nav PVT, and if you go down the bottom we'll see the NMEA messages there as well. So these are all the message types that this GPS module or U-Blox, Microbox modules in general are capable of outputting, I think. Now notice that there's this other window down the bottom with some bytes. Yes, you're getting the idea already, aren't you? But when I select a different item in this list, the bytes at the bottom will be changing. They don't change a whole lot, but they are changing. So let's go up to POS-LLH. Now this window down at the bottom it's laid out like a hex editor almost, because you have an address label at the left, and then you have a list of the bytes showing them in hexadecimal. This is the binary display, and then over on the right we have an ASCII format display representing whatever these bytes are here. So the first 2 bytes you can see, this is the Microbox header, this is just the micro B, that's this B562 pair of bytes at the beginning that makes up the header on the beginning of every Microbox message. Alright, now keep an eye on these 1, 2, 3, 4, 5 bytes there. Now they're all 0 at the moment, and they correspond to these checkboxes being on or off. So if I select the middle checkbox, you'll see that the middle byte goes to a 1, and select those 2 there, then we got the last 3 bytes become a 1. So this is essentially, this little set of bytes at the bottom is essentially encapsulating this set of settings that we've made. And we can send this string of bytes to the GPS module, and it will apply this setting as if we made this setting in the GUI like we just did. One thing to keep in mind though here is you can't just, for example, if I went to my now that we know that these zeros here are the checkboxes in the GUI that we just played with, we might think, oh well, we'll just change this one here to a 1 like that and it will work, because that's how it worked in the GUI. But you can't do that, unfortunately. So keep an eye now on the last 2 bytes of this row. When I change something, you'll see the last 2 bytes changing as well, because those last 2 bytes are the checksum for this overall message, and they rely on the content of the message. So unless you're very good at calculating those checksums in your head, or you have some nice way of doing it, I would recommend just using this Micro Center application to get these checksums correct. And it makes things much easier to do. So because all you need to do is copy this into your Arduino. So let's see. Oh yeah. So anyway, so what you want for using this with Arduino is UART1. Seems to be the case, at least with all the GPS modules I've tried. So as an example, let's choose POS-LLH, and we'll turn that on, and then copy this string of bytes and bring that into our program. And I've already done this, but I'll just put it in here to show you how easy it is. You just need an 0x there, and then you need a comma 0x there, and then if we search for spaces, then we can just do this. So this is what I've done for those other lines that are there already. And you'll see that this line that I just put in has the exact same contents as this line above here, which has been commented as nav pos LLH on. So that's where those numbers come from. Not so daunting looking now, is it? All you need to do is copy and paste them in, basically. There is another thing to keep in mind, though. They work sequentially. So, for example, these ones down here where I've set the rate to, for example, 10 Hertz, 5 Hertz, and 1 Hertz, I did that by, there's a few other things you can do in the settings wise. So this one down here, if you click on rates, you'll see, again, there's a set of bytes here. So this is what I've used to set. This would be 1 Hertz in that case. And if you change this to 200 milliseconds, you'll get a 5 Hertz update. So this is where I've copied those strings of bytes from. But what I wanted to point out is that because they're processed sequentially, the result of what we've done here is that we're going to set the output rate to 10 Hertz, then we're going to set it to 5 Hertz, and then we're going to set it to 1 Hertz, and only one of these is actually going to take effect, and it will be the last one that we did. So essentially these two lines here are overriding the first line. Well, they're overriding all the settings before them for this particular setting, because it's just a single number, really. What is the rate? So the effect that we have from these three lines would be the same as if we had those two lines commented out. It wouldn't make any difference. So let's just show you what I mean there. I think I have a yeah. So that's the program that's running here is this one here that we just looked at with the multiple messages. So we're using the POS LLH and the nav status, and we're just printing out some simple display like that. So that's what's going on there. So if I go to my, and it's running at 1 Hertz, right? So if I go now to my set messages program and I comment out this last one where I'm setting it to 1 Hertz and run it or upload it, so this will have the effect of setting the rate to 5 Hertz for the GPS module. Now if I go back over to my program that actually does something and upload this one again, now we should be able to see that it's a 5 Hertz update rate. And likewise we could do 10 Hertz. Not all of these modules do 10 Hertz update, by the way, but this one does. So I'll just give that a moment to run. I'm not sure how long it takes, probably doesn't take very long, but now we should have 10 Hertz. Alright, well that seems to work nicely. So just wanted to do that to illustrate the fact that these are going to overwrite. If they're applying to the same setting, they're going to overwrite whatever was done before. So you can just keep adding as many of these as you like into this array. I suppose you might get to some limitations soon because there's not unlimited memory, but alright, so another thing I wanted to point out was this setting here is not saved to the EEPROM. It's only in action until you turn the GPS module off. So if you turn it off and on, whatever you've done here is not going to be, it's not going to save, they're not going to change anything permanently, which is actually kind of nice, because if you unplug the module from your Arduino, whatever you're using it for, and plug it back into something else that expects to have the default NMEA messages, well then it'll work. And then when you plug it back into your Arduino program, as long as you've done this at the beginning of it, then it will work for yours as well. So you never really have to connect it up to this Micro Center application again, which is really handy. Now you might be wondering why I've got disable UBX and then enable UBX. And the reason for that is that I wasted about an hour before making this video trying to figure out why my program wasn't working, just this one with the multiple messages. And the reason was that I'd forgotten that I turned the nav PVT message on. So I didn't have this bit here, It was just like that. So I commented this out, and I thought, well, I commented out the turning the nav PVT on, so I shouldn't be getting any nav PVT messages. But like I just said, it remains in action until you turn the GPS module off and on again. And I hadn't turned the GPS module off, so the nav PVT on instruction that I'd given it earlier was still in effect. So I was getting all three types of messages. So what I decided to do to make sure that kind of thing doesn't happen in the future was first do disable UBX for all of the message types that I've been using, which was these three. And then down here I'll re-enable whichever ones I want to use right now. So that's why I have just these two, the second two of these lines uncommented. So that's just another thing to keep in mind. Of course, if you want to turn the GPS module off and on, well, I guess that's not necessary, but I thought it's just safer to make sure you're turning off the things that you wanted to, that you thought that you had off, just to make sure. So I think that's about all I wanted to say. I will put these programs up on my website, of course, and I'll also put up a link somewhere to this spreadsheet just in case it's handy for people. But I think that's about all I wanted to look at. Yeah. Okay. Thanks for watching. See you later.